Hello everybody, and welcome to the next video in our GMAT Ninja Quant series. My name's Harry Duthie, I'm one of the tutors at GMAT Ninja, and today we're going to be talking to you about ratios. Now, a quick warning before we get into this video is going to be on the easier end of our spectrum. While there are a few questions towards the end that might challenge you if you're in the low to mid 40s, there's nothing here that's going to blow your head off. Today, we're really looking to build on the fundamentals, to get the processes down. And so if you're looking for something in the sort of Q50, Q51 range, this video might not be for you. If you struggle with ratios, feel free to stick around, but just as a warning, this video is not going to be that tough. I mean, the people that we are aiming this video at are those of you that really struggle to get ratios questions going. But if you look at a ratio question and struggle to translate that onto the page, struggle to see how to get it started, then we'll definitely have things for you. Similarly, if you're looking at a ratios question and all you know how to do is throw numbers at it, if you're not sure how to use algebra or when to use algebra, when it's appropriate, then again, we're going to have plenty of things here for you today. And finally, if you've got a process, but you don't quite understand how or why it works, and if you just memorize a formula, memorize something, then today we're going to look at, hopefully get underneath these questions and look at how and why they work. Now, as we go through today, I've got 8 questions for you, and each time I'm going to put them up on the screen. I'll give you a couple of minutes to take a look at them, and then we'll come back together to walk through them and to explain what's going on in each one. Over the course of this video, I'm aiming to cover, well, first of all, basic ratios. What are they? How do we use them? Why do we use them? Then other questions like changing the ratio as the situation changes, or combining or separating ratios, and those triple ratios questions where maybe you get 2 ratios and we need to push them together into one big ratio of 3. As I say, we've got a couple of questions that'll challenge you towards the end, but certainly in the early questions, I'm really looking at the basics. So the first few are not going to be too difficult. If you're looking for a challenge, feel free to stick around and we'll get to some of those a little later. So without any further ado, I'll get the first question up on the screen. We'll give you a couple of minutes to take a look at it, and I'll see you back here soon. Okay, now's the time to pause the video. If you need a little more time to look at this question, I'm going to take it away so that we can take a closer look at this one. So, while we've got a question to look at, I'm going to take a step back and just look at what ratios are and how we can write them just for a second, because there's a couple of different ways of looking at them, and one of them is certainly more helpful than the other in dealing with this question. So I'm going to ignore the blue text over here for now, and I'm just going to look at this short example up here in the black pen to begin with. So the ratio of x to y is 5 to 2. Now, typically when we give that to our students, they will immediately say something like, well, that means x to y is 5 to 2. And that's absolutely correct. There's absolutely nothing wrong with that. That is precisely what that says. But there's another way of writing ratios. And this second way can be more helpful, certainly in a question like this. Another way of writing the ratio of x to y is to say, well, I could write that as x over y. And on the other side, if that ratio is 5 to 2, then that ratio is 5 over 2. Now, you can directly translate between these two types of ratios, and we might see that a little later in this question. But just, yeah, bear that in mind. As we've spoken about in some of the previous videos, having the flexibility to jump between two different methods will help you a lot on the GMAT. And if you've got two different ways of writing a ratio, you can choose which method you use. Now, as I say, we're going to come back to that in a second when we dig closer into this question. Now, huge great wall of text here. If you're struggling to figure out how to convert that into algebra, then maybe you want to take a look at the first word problems video that we've got, the algebra translations one. In this video, I'm really going to be focusing on the ratios part of this. So pulling this question apart, we've got this second sentence that gives us a lot of information here. If the average, so the arithmetic mean, number of sweets each child buys is equal to 5 times the number of sweets that adult buys, from that we can set up an equation here. So the average number of sweets, if I say that A is going to be the number of sweets that Adil buys, B is the number that Beta buys, and C is the number of Clara buys, then the arithmetic mean of the number of sweets each child buys is going to be A plus B plus C divided by 3. And that, we're told, is equal to 5 times the number of sweets Adil buys. Now, what I'm aiming for at the end of this is the ratio of the number of sweets Adil buys to the number of sweets that Beta and Clara buy. So eventually, I'm looking for something that's A to B plus C. Or in other words, as we said, that's the same as saying A divided by B plus C. If I can arrange this expression into either of these formats, then I'm going to be able to translate that into my answer. So with this one, I've got a B and a C here. I've got some A's. Why don't I group the A's together, keep the B's and the C's together, and then I'll see where I end up. So first job, I'm going to multiply both sides here by 3. And so I'll get A plus B plus C equals 15A. And if I subtract A from both sides, I'll get B plus C is 14A. Well, now if I group the B and the C together, divide both sides by B plus C, and then divide both sides by 14. Well, now I've got something in one of the formats I was looking at before. So A over B plus C is 1 over 14. I'm almost there. The answer choices have the other way of representing a ratio with the colon in the middle beforehand. So I just need to translate this from the A over B plus C format to the A to the B plus C format. Now we can come back up to the example here. The X over Y, so X was the 5, Y was the 2. So the ratio here, the A is going to go with the 1, the B plus C is going to go with the 14. I can directly translate that ratio when it was a fraction into that ratio when it's a colon, with a colon in the middle. And from that, A to B plus C, the ratio of the number of sweets Adil buys to the ratio of the number of sweets that Beta and Clara buy is 1 to 14. So the answer here is B. Now, with ratios questions, it's very important to pay an awful lot of attention to the order that they put the question in. In this case, the ratio of the number of sweets Adil buys to the ratio of the number of sweets that Beta and Clara buy. A comes first, then the B plus C comes second. It's very easy when you're reading these questions to slip up and just get those the other way around, in which case you might have thought E was the answer here. So as we've said in the algebra translation video, whenever you're looking at these word problems, take your time, preferably read the question twice, and just be very certain about what you're being asked to do. All right. That's the end of the first question. I will get the second question up on the screen for you right now, and we'll take a look at that one. You've got 2 minutes, a couple of minutes, and I will see you back here soon. Okay, folks, as usual, now's the time to pause it. If you need a little more time to work on this one, I'm going to take the question away now so that we can take a closer look. So in the last question, we began looking at where you could use fractions in ratios questions. Yeah, we saw two different ways of looking at a ratio. In this question, I'm going to start introducing the algebra. So what we could say here, we've got this fruit bowl that contains lemons and limes in the ratio 7:5. Now, I don't know how many there are in total. There could be 7 lemons, 5 limes, if I've got that the right way around. Yep, 7 lemons, 5 limes. There could be 14 lemons, 10 limes. There could be 21 lemons, 15 limes. I just don't know. What I can say is the ratio of lemons to limes is equal to 7:5. But what I can do is introduce some algebra to represent the actual number of lemons and limes. As I say, I don't know how many there are in total, but if I include a variable, x there, 7x to 5x, that still keeps the initial ratio. It still means that my ratio of lemons to limes is 7:5. But now, rather than representing the ratio of lemons to limes in the fruit bowl, this represents the ratio of the actual number of lemons and limes in there. If I knew what x was, then I'd be able to tell you the exact number. For example, if x was 3, this would be 21 to 15. The ratio would still cancel to 7:5, but I would know the actual number of fruit in the bowl. And that process, that piece of information is going to become very useful later on. For this question, what I can say is that the total number of fruits, so the number of lemons plus the number of limes, would be equal to 7x plus 5x, or adding those together, 12x. So what I can say from that is that the total number of fruit in the fruit bowl is going to be some multiple of 12. 12, 24, 36, 48, so on. And I can very quickly use that to go and check off these answer choices. So yeah, if I know that the total number of fruit in the fruit bowl needs to be in the 12 times table, well, I can say that number 1, yeah, that's 12 times 2. Yeah, that is a possibility. 44, that is not a possibility because 44 is not in the 12 times table, and 60, yeah, it's 12 times 5, so that's in. So from that, we can very quickly say that number 1 and number 3 are the options. Yeah, that could be the total number of lemons and limes in the fruit bowl, which means that D is the answer to this question. That was, yeah, hopefully a nice and quick question, but remember, that's where we're introducing the algebra here, and that's how you can change a ratio from looking at, yeah, this is the ratio of the number of items I've got here, to representing the total number. And that's going to become very useful in later questions. All right, I will get the next question up on the screen. As we move on, the questions will slowly begin to be a bit more challenging. I know the first two have been very easy, but we're going to use the ideas we've seen in these first two questions as the questions get more difficult as the video continues. So I'll see you back here in a couple of minutes after we've given you a chance to have a go at this next one. Okay, pause the video now if you want a little bit more time to take a look at this one. I'm going to take it away so that we can work through this one together. Right, so a few things going on with this question. Eventually, I want to get to the ratio of dogs to hamsters, but the information we're being given links the dogs to the cats and the cats to the hamsters. So thinking this question through, I'm going to find a ratio for dogs to cats. I'm going to find a ratio for cats to hamsters. I'm going to push those two ratios together so we get a single ratio dogs, cats, hamsters. Then I'm going to pull out the dogs and the hamsters from that, and I'm going to have one ratio for those two. Now, first job when we're doing that is we need to get the two separate ratios, and we've been given the question given the information in different ways. The first bit talks about the dogs and the cats. I've been told there are 4 dogs for every 3 cats. Now that should, if you think about that, should make it fairly simple to turn this into a ratio. If I've got 4 dogs for every 3 cats, the ratio between dogs and cats will be 4 to 3. 4 dogs, 3 cats. If there were 8 dogs, 6 cats, so that ratio builds up, but there are still 4 dogs for every 3 cats. So we've got our first ratio there. We just need to find the ratio of cats to hamsters. Now, the way this has been phrased might be a little bit more difficult. If you can jump straight from there are 5 times as many cats as hamsters into a ratio, fantastic, go for it. If you can't, it might be easier to turn that into an equation first. As it said, there are 5 times as many cats as hamsters. So we could turn that into the equation cats equals 5 times the hamsters. Now, remember that the way we could write these ratios, the ratio C over H is this, well, gives us the same information as the ratio C to H. So I can turn this equation and divide various things, cross multiply and divide until I get to C over H equals some number, and I can turn that into a ratio. Now, using this, C equals 5H, if I divide both sides by H, that leaves me with a 5 on that side, but if I put that 5 over 1, well, now I can turn this equation, C over H equals 5 over 1, into the ratio C to H equals 5 to 1. So if you're reading a ratios question and you think, I'm not sure how to turn that into a ratio, but I can turn that into an equation, then you've got a method that will help you convert it into a ratio. It might take a couple of steps more, but better to take the extra time and get the ratio right than to rush it, do something you're not sure of, and make an unnecessary mistake. So now I've got my ratios. I've got my dog to cat ratio. I've got my cat to hamster ratio. It's just a case of pulling them together. Now, turning 2 ratios of 2 things into a single ratio of 3 things, what I would do here is set up cats to dogs to hamsters like that. And I can put my cats to dogs, just being very careful. I've turned the ratio around there. And cats to hamsters is the ratio of 5 to 1. Now, in looking at this, when you're turning as I say, 2 ratios of 2 things into 1 ratio of 3 things, there should be one item where you've got both, that's in the top and the bottom ratio here. And what we need to do is find the lowest common multiple of the 2 numbers here, the 3 and the 5. In this case, lowest common multiple of 3 and 5 will give us 15. And now I just need to find what the dogs and the hamsters would be in that ratio. Now, the question you've got to ask yourself here for the dogs is, what do I times the 3 by to get to 15? In this case, it would be 5. And so you times the 4 by the same thing, and I'm going to get 4 times 5 would give me 20. Similarly, for the hamsters, I've got to ask, what would I times the 5 by to get 15? In this case, it'd be 3. And so I would do the same to the hamsters, which was 1 times 3, which will give me 3 overall. So my ratio of cats to dogs to hamsters will be 15 to 20 to 3. Nothing simplifies any further there. I can't cancel any of these numbers down. And the ratio of dogs to hamsters, which is what I want at the end, I can just pull that out of this ratio and just say dogs to hamsters is going to be 20 to 3. And that will give me the answer E in this question. So with these, as with most of these questions, you've got to be able to convert the text into algebra. Now, if you can't go straight from the text into the ratio, feel free to go from the text into an equation, and you can use that equation to get you to the ratio. As we said here, line the 2 ratios you have up underneath a heading of all 3. You're looking for whichever value in both ratios you have in both of them. Find the lowest common multiple of those two numbers. That'll give you the 15 here. You convert the other two down, and you can just pull these two numbers out of the ratio to give you the ratio of dogs to hamsters there. All right. Now, converting between two ratios or two things into one of three. Again, another very useful skill when dealing with ratios. But we'll move on. I'll get the next question up on the screen. We'll see you back here in a couple of minutes. Okay, folks, now's the opportunity to pause it if you need a little more time on this one. I'm going to take the question away so that we can look at this one together. Okay, so this question plays on the difference between knowing the ratio and knowing the absolute number of items involved here. So we're told the ratio before some set of changes, but we've no idea about the total number of items involved, no idea about the number of cars and trucks in the toy box before I lose my 2 cars and go and buy 8 more trucks. I get given the ratio afterwards. I know that's 3 to 2, but I've no idea what the absolute number of cars and trucks in the toy box is afterwards either. If I knew either of those things, this would be much, much easier, but I don't. We've got to find a way around that. So we've got to find a way of playing with the ratio at the beginning, the ratio at the end, and knowledge about the absolute number of changes in the middle. Now, if you think back to question 2, when we were looking at the lemons and limes, I converted that 7 to 5, the ratio of 7 lemons to 5 limes, into something that represented the overall number by doing the 7x to 5x. At that point, even though I didn't know what x was, I had something that could represent the total number of lemons to the total number of limes. And we're going to do something very similar here. So I know at the start that the ratio of my cars to trucks in the toy box is 5 to 2. And again, I can say something that would be similar to, so cars to trucks is 5 to 2, but I could say something like the total number is 5x to 2x if I knew what x was. See, I don't at the minute, but that's where this question is going to go. Now, what I get is I've got that absolute number there. Now I can make some changes, but that would tell me the total number of cars and trucks I've got after the changes, which would be equal to the final ratio. So I can set up a bit of an equation here. I've got my 5x and my 2x, and so let me put that in a fraction for this ratio, because the fractions are going to make this question a bit easier. Now you can see I've made this line a lot longer than just 5x to 2x because we can incorporate the changes here. So I'm going to lose 2 cars. Now cars are my top line, so I'm going to lose 2 cars on the top line. And my trucks are on the bottom line, and I've bought a set of 8 trucks. So now the 5x and the 2x was the total number of cars and trucks I had at the start of the situation. I've lost 2 cars, I've bought 8 trucks, and so this is the total number of cars and trucks I've got in the toy box after the changes. Now again, I don't know what the x is, but if I did, this would give me some numbers. I could cancel those numbers down, and that would equal the ratio 3 to 2 that I was given earlier. Now I've got an equation, and I've got a way into this question. And this is one of those questions that once you've got this equation, we're about 75% of the way done. All I need to do now is go and solve this equation and go and find x. So on this, I can cross multiply both sides. So if I times both sides by 2 and times both sides by 2x plus 8, I'll get this line. Expanding the brackets will give me 10x minus 4 is equal to 6x plus 24. If I take away 6x from both sides and add 4 to both sides, I'll end up with 4x equals 28, and so x equals 7. Now, at this point, we've got to be careful. We've got to the end of the equation. We might think that's enough to get the question done. But this is where you need to be very careful with, what do I actually mean by the x value here? And just keep track of your variables as you're going. This x does not represent either the number of cars or the number of trucks. So don't get sucked in and just jump straight to b as the answer because you found x is 7. What we need is how many trucks did I have originally? And if I go back to my initial equation, the trucks there, well, that was 2x, not just x. So if I multiply both sides by 2 there, I'll get 14. And so the actual number of trucks I had to begin with is D, is 14. All right, so as I said earlier, this question is one of those that once you get the equation onto the page, you're about 75% of the way there. All you need to do is think about that difference between have I been given the ratio. I can convert that into something that doesn't tell me the actual number, but represents the actual number of items, in this case, the cars and the trucks in this. Once you've got that, then we can put into place the changes, and that overall ratio will represent the same things as the ratio after the changes. You get that equation set up on the board. Now you can work your way down it. You find the x value. Be careful at that point, you're not done. Continually remind you of this. Be careful exactly what the question's asking for. All right, I will get the next question up on the screen then, and I will see you back here in a couple of minutes' time when we can look at that one. Okay, now's the time to pause it if you need a little more time on this one, but I'm going to take it away so that we can look at this one together. Right, so now we're beginning to bring inequalities into this. And so one of the first things we need to do with this question is to convert it into algebra. Now, in a very similar way to the way we did in the algebra translations video, I'm going to read this one very literally. Now, the first sentence, at a swimming pool, okay, don't really need that, but the ratio of lifeguards to swimmers must be at least 3 to 10. Now, again, if you're using the lifeguards to swimmers way of looking at things, that's going to make things a little more difficult in this question. If I could write that as the ratio of lifeguards to swimmers must be at least 3 to 10, well, then I've got to weigh into this question. Now, what I'm looking for is if there are 7 lifeguards on duty on Saturdays, what is the maximum number of swimmers allowed? So really, I'm looking for what is S when L is 7. And maybe the phrasing of that, what is S, isn't really the way of looking at it. I'm looking to use this inequality. I want to find what S can be in that inequality when L is equal to 7. So I could put 7 over S is greater than 3 over 10, and then start rearranging. Because I know that everything here has to be positive, I can't have a negative number of swimmers, then I can just cross multiply within this inequality. So multiplying both sides by 10 and multiplying both sides by S would give me 70 is greater than 3S. And then dividing both sides by 3, 70 divided by 3 will be 23.333333, 23 and a third. And so now I can say that S must be less than 23. But the question is asking me what's the maximum number of swimmers allowed. Now, I can't have a third of a swimmer. That would be very weird floating around the swimming pool. And so I need to round this down to the nearest whole number, because 23 will be the biggest number of swimmers that will be allowed in the swimming pool that is still less than 23.333. I can't really go up to 24 because 24 would be bigger than the maximum number allowed. And there's no point going down to 22 or 21 or 20 because I can go all the way up to 23. So 23 is the maximum number of swimmers I'm allowed while staying within the boundary of this question where the number of lifeguards is 7. And so the correct answer here is D. So this is taking us back to the algebra translations videos before. As we've said in that one, if you've got a question like this, be as literal as possible with how the question is worded, and that should help you get things started and set up. And from there, it's just a case of following the algebra. All right, I will get this question out the way. We'll get the next one on the screen, and we'll see you back here in a couple of minutes' time. Okay, there's a lot going on in this question, so if you need a little more time, now's the time to pause it. You can always catch us up. I'm going to take the question away so that we can take a closer look at it now. All right, as I said, yeah, there's a lot going on in this question. There's a lot of writing here. A couple of things to focus on are to be very careful with the variables, be careful how you write things out, how you lay things out so that you don't get confused with your own working. So what we can say to begin with is our ratio for coffee, or the ratio of orders for coffee to tea to water, is 5 to 6 to 10. That's our ratio in the morning. Now, in the afternoon, we're going to have to make a couple of changes, and we'll deal with those in a second. And then we get to what is the minimum number of coffee orders that could have been made in the afternoon. So what I'm thinking is going to happen here is we've got this ratio of all 3 items. I'm going to have to split that apart in various ways. We're going to make some changes. We're going to push it back together. And from that, we're going to look at the minimum number of coffee orders we're going to make. So first thing we're told is the ratio of orders for coffee to tea tripled. So I'm going to pull out just my ratio for coffee to tea. That's equal to 5 to 6. And we're told there that the ratio tripled. Now, one of the big mistakes that lots of our students make at this point is to say, right, the ratio tripled. So I'm going to times both numbers by 3. I'm going to get 15 to 18. The problem with that is that cancels it down immediately back down to 5 to 6, and you've not actually made any changes. When you're being told about changes to ratios like this, it can often, almost always, be easier to understand what's going on if we don't write this as this variation of looking at ratios with the colon in the middle, but look at them as fractions instead. So I could rewrite this as coffee to tea is 5/6. Now, if I tell you that that ratio tripled, that's the same as saying, well, the new ratio of coffee to tea is 5/6 times 3. I've tripled the ratio. The ratio was 5/6. I triple it. I times it by 3, and that gives me 15/6. So in the afternoon, the ratio of orders for coffee to tea tripled. So the ratio of coffee to tea is now going to be 15/6. And I know that cancels, but I'm not going to do that yet because I don't know what happens in the other changing ratio. It might be easier to leave that and deal with it later. So the other side of this, I get told the ratio for orders of coffee to water halved. So coffee to water is 5/10. Now, in this, using the same way of looking at things, it's much easier to see how that halves. So the ratio halves. If I write that as, it's 5/10. So now my new ratio of coffee to water is going to be 5/10 times by a half, or in other words, 5/20. Right, so my ratio of coffee to water is going to be 5/20. Right, so yeah, now we can see that, 15/6, coffee to water 5/6, and coffee to tea 15/6, and coffee to water 5/20. It would be more simple if I simplify this down, I can divide both bits of the ratio by 3, and I'm going to end up with 5/2. Yeah, I could have done that earlier, but I don't know whether that would be a wasted effort. I can leave that until now. Now, as we did before, what I want to do is pull this ratio back into one ratio of 3 items. And as we did a couple of questions ago, I'm going to write that as 5/2 for coffee to tea and 5/20 for coffee to water. But this time, the two numbers in the coffee bank are the same, so I can just pull that down. Tea is going to be 2, water is going to be 20. So my overall ratio for the number of orders in this coffee shop for coffee to tea to water is going to be 5/2 to 20. Because there's no common divisor for those three numbers, there's nothing I can simplify by, there's nothing I can divide down by, the minimum number of orders for coffee in this shop in the afternoon would have been 5. And so that leaves me with an answer of D here. Right, so as you can see in this question, if you're trying to pull out 2 from 3, as we did there with the coffee and the tea and the coffee and water, you can just extract them. But when you get into changing the ratios, if you want to triple it, double it, multiply it by 5, half it, quarter it, it's much easier to do, and it is much more intuitive if you write these ratios as fractions. You can make the change, then if you need to, you can put them back into this form with a colon in between. All right. That's enough for that question. I will get this one out the way, and we'll get the next one up on screen for you. I'll see you back here in a couple of minutes. Okay, there's a lot of algebra in this one, so I wouldn't be surprised if you need a little more time. If you do, now's your opportunity to pause the video. We're going to take a closer look at this one once I take it away. All right, so yeah, as I said here, there's a lot of algebra in this one. Yeah, the difficulty level stepped up a fair bit. And what we need to do is find the percentage change in the ratio. So we've got ratios and percentages going on in this question. So yeah, first job, percentage change. The way we're going to do that is to have the new value minus the old value divided by the old value and times the whole thing by 100. Now, what we've got to do is figure out what the new value and the old value should be. The old one is easier, so we're going to do that one first. We're looking for the ratio of the cost of renting an apartment to the cost of buying an apartment. Now, in this whole thing, we've not been given any variables for that, so I'm going to use the variable. I'm going to say capital R is the cost of renting, and capital B is the cost of buying. So the old ratio is just going to be R over B, the ratio of the cost of renting to the cost of buying. Now, the new ratio is a little bit different. I've got to figure out what they cost, the cost of renting and the cost of buying in terms of R and B after the cost of renting rose by P% and the cost of buying rose by Q%. So I could say that the new renting cost is going to be R times 1 plus P over 100. So I'm going to increase the rental cost by P%. Similarly, for the new buying cost, that's going to be B times 1 plus Q over 100. And so my new ratio is going to be the top line divided by the bottom line. So R times 1 plus P over 100 divided by B times 1 plus Q over 100. And now I can set up the whole expression. It's going to be R 1 plus P over 100 divided by B 1 plus Q over 100 minus R over B. The whole thing's going to be divided by R over B, and whatever I get out of all of that, I'm going to times it by 100. Now, we can, and we'll have to simplify this. As you can see, none of the answer choices include any R's or B's. Now, thankfully, every term has a common term. Every term in this fraction has a common term of R over B. I'm going to jump right to this. We can cancel the R over B in every expression. If you need a little bit more time just to check that, confirm that, feel free to pause the video now, run through the algebra. You divide the fractions through, you will be able to see that we're going to get rid of the R over B there. And so what we can say that this becomes, this whole thing is going to equal 1 plus P over 100 over 1 plus Q over 100 minus 1 over 1. The bottom line, where this R over B on the bottom line of the big fraction, that's disappeared because that was just 1. And then the whole thing, once we figure this out, will be times by 100. Now, within this set of parentheses, within this, I'm going to take this first term and times top and bottom by 100, just to simplify things. I want to get rid of the P over 100 and the Q over 100. I don't want to have fractions within fractions. So if I times top and bottom by 100 over 100 here, I get 100 plus P over 100 plus Q minus 1 over 1. And I've still got that times 100 on the end. Well, now I've just got a fraction subtraction within this set of parentheses. So if I give them a common denominator, it's 100 plus P over 100 plus Q minus 100 plus Q over 100 plus Q. And this whole thing is still times by 100. So now I'll come up here. What we can see here, I've got 100 plus P minus 100 plus Q. The hundreds are going to cancel. And I'm going to end up with P minus Q over 100 plus Q, and the whole thing still times by 100 on the outside, which leaves me, final step, if I bring that 100 on the inside, multiply the top line through, 100 times P minus Q over 100 plus Q, and checking the answer choices that this one matches D, and that's going to be our answer. So as we've seen before, this has ramped up the difficulty level fairly significantly, but that all comes from how nasty the algebra is once you get into the question. As we've said before, with some of these great big word problems, you've got to be as literal as possible with how you set them up. So here, what was the percentage change? So we're looking for a percentage change, and we can go to percentage change formula, and that percentage change in the ratio. So all of our terms, the new and the old terms in the percentage change formulas, are going to be ratios. And once you figure this out, once you break this down into different bits and pieces and find each one in turn, and once you get that equation on the page, okay, the algebra is pretty horrible in this one, but getting to that equation is most of the battle there. Once you're there, it's a case of manipulating the algebra and being careful with what you've done so that you get to the answer. Now, you might have found it as we're going through, you might have found it quite repetitive that I kept saying I'm going to multiply that 100 on the end. Now, that's more as a reminder for me. I'm just trying to be careful. In writing this, we did this question about 20 times, and I kept going for C because I kept forgetting the 100 there. And these small mistakes are the things that will really kill your score if you're doing the GMAT. And if you can find any way you want to remind yourself, that will help you prevent those errors, prevent the unnecessary ones, the sorts of ones where you look back on a question and go, why did I do that? Because those are the ones that really kill your score. If it's helpful to just repeat things as you're going on, it might be annoying when you're doing it on video, but it can really help your score in the long run. All right, I've got one more question for you. And as we said, the last two are going to ramp up the difficulty level fairly significantly. So I'm going to give you a little bit more time to work on this one. I'll see you back here in a couple of minutes' time. Okay, there's plenty to think about in this one, so I wouldn't be surprised if you need a little more time to have a go at this one. Feel free to pause the video now if you want a bit more time, but I'm going to take it away so that we can look at this one together. Now, there's there's probably more than two, but there's two main ways of looking at this one. We can either think about it algebraically, or, and far quicker, we could think about it intuitively. If you can see the intuition, great, this question actually doesn't take that long. If you have to go algebraically, there's a way of doing it. You can get there fairly quickly, but it's going to take a little bit longer. What we'll do is I'll show you the algebraic way through this, and then we'll discuss the intuitive way of looking at it. So what I would do to begin with is begin to set up the question. As before, there's a huge, great amount of text here. And if we can turn this into algebra and to say, what is this question actually asking me? Then I can be a little bit more clear about the information I need and what I've been given. And so what we're saying here is every student's either a French major or a Spanish major, but not both. You're in one of two camps and you can't be in the middle. But what we're asked is the ratio for French majors to Spanish majors greater for the women than for the university as a whole? So what I could say there, I could set up the ratio of French majors to Spanish majors, and I'm using the subscript W there to represent that this is the ratio for the women. And is that greater than for the university as a whole? Now, yeah, I could say F with the subscript U and S with the subscript U to represent university. But what I could also do is say that that's the same as saying ratio of French for the women and French for the men to Spanish for the women and Spanish for the men. That's the university as a whole. Now, I can push this question a little bit. What I mean by pushing the question is I can play around with the algebra to say that, is this really what the question's asking? Now, I've got some fractions here in an inequality, but because these are people, all the terms are positive. So the denominators, the numerators of everything in this fraction is a positive term, because I can't have a negative number of people. So I can cross multiply here. So this question is the same as saying this, which is not particularly helpful to begin with. But if I keep playing around with the algebra, if I expand these brackets, so French women times Spanish women plus French women times Spanish men, is that greater than Spanish women times French women plus Spanish women times French men? And what we can see is on both sides, I've got a Spanish woman, French woman term. And so I could subtract that from both sides. So this question is the number of French women times the number of Spanish men greater than the number of Spanish women times the number of French men, which still doesn't look very helpful until I go and divide back and say, well, let's divide both sides by Spanish women and divide both sides by the number of Spanish men. And this question changes from, is the ratio of French to Spanish majors greater for the women than for the university as a whole, to, was the ratio of majors for the women greater than the ratio of the majors for the men? Now, we can go and use that. And what we can say is in number one, we're going to be given a very similar thing. The ratio of the number of French majors to Spanish majors is greater for the university as a whole than for the men. And so we get French women plus French men over Spanish women plus Spanish men is greater than for the men. Now, I'm not going to go through the process again. You've just seen it. It's a very similar process to what we've just done there. But what we can show by cross-multiplying, expanding the brackets, simplifying, and dividing back down is for this one, we can say that the ratio of majors for the French to Spanish for the men is going to be less than that ratio for the women. And I'll leave you to play around with the algebra there, but you can show that getting from here to here using the same process we've just done there. Well, this is exactly what we were looking for. Yeah, we were asking, is the ratio of French and Spanish for the women greater than the ratio of French and Spanish for the men? And number one tells us exactly that. So on my AD over BCE setup, I can cross out BCE, and I'm left with A or D. Now, looking at number two, we can see that fewer than half of the French majors, but more than half of the Spanish majors are men. Well, if these people, if there's only men and women, and they either have to be a French major or a Spanish major, then if fewer than half the French majors are men, then more than half of the French majors have to be women. Similarly, if more than half of the Spanish majors are men, then that has to be greater than the number of Spanish majors who are women. And so looking back at this question that we've got here, the number of French women is greater than the number of French men. So the numerator on the left-hand side is greater than the numerator on the right-hand side. And the number of Spanish men is greater than the number of Spanish women. So the denominator on the right-hand side is greater than the denominator on the left-hand side. So here I've got a bigger number divided by a smaller number on the left-hand side compared to the right-hand side. So I can very comfortably say that this side, the left-hand side, the ratio is going to be bigger. Yeah, big number divided by small number is going to be bigger than small number divided by big number. So I can say, yes, the ratio of French majors to Spanish majors is going to be greater than women than for the men. And working my way back up to the top as we did at the start, that would answer the question that I'm looking for. So the answer here is we're going to cross out A and we're going to be left with D. So you can do this algebraically. But as we've seen there, this question sort of decomposes down to a comparison of the ratio for French to Spanish for the women to the men. Now, the intuitive way that I mentioned earlier is to notice that in this university, we're looking for the ratios of women to overall to the men. Now, because everybody in this university can either be man or a woman here, that we've got two options. That either the ratio for the women will be greater than the university, which will be greater than the men, or the ratio for the women will be less than the university, which will be less than the men, because the overall ratio has to be between the women and the men. You can play around with this as much as you like. If we set this up at the top here with the ratio French from men to Spanish from men, pick any numbers you like for the ratio. So the number of men taking French, women taking French, men taking Spanish, women taking Spanish, the ratio for the overall will end up in between the two of them. Now, if you can see that, you can skip from here down to here very quickly. Number one tells us that the ratio for the ratio of French majors to Spanish majors is greater for the university than for the men, which would put you in this top line down here, which answers the question straight away, because we get that the ratio for the university is greater than the men. Well, the women has to be greater than the university then. And the second one, using a very similar process that we did when we were looking at the algebra, thinking that, well, if the number of French women is greater than the number of French men and the number of Spanish women is less than the number of Spanish men, then the ratio for the women is going to be greater than the ratio for the men. And that gives us the information we need to talk about compare the women to the university. So you can do this algebraically. You have to be careful. There's a lot of subscripts going on. There's a lot of moving terms around. But as you can see, it is possible. But if you can spot that intuition that the overall has to be in some way between the two components, then you can jump very quickly through this question. Right, so that's all I've got for you today on ratios. As we said, this was more about getting the fundamentals in there and helping you to understand what you can do with them. So the things we hope you take away, I mean, first of all, we've got the word problem bits about reading the question literally, trying to translate straight from the page into algebra. But when you get into the ratios, remember, you can write it with the colon or you can write it with the fraction. You can include the algebra. If you think back to the lemons and limes question, I can find an expression that changes me from the ratio to the total number of lemons and the total number of limes. And that becomes very useful, especially when we get into the changing ratio scenarios or the triple ratio scenarios. And with those triple ratios, remember about pulling them apart and pushing them back together again. And then when you're trying to triple a ratio, half a ratio, double a ratio, something like that, that fraction setup becomes a lot more useful. So I hope this session has been helpful for you, and hopefully we'll see you back here again sometime soon for the next in our series of GMAT Ninja Quant videos. Thank you very much. We'll see you again sometime soon.